Alright, cool. So a minimum spanning tree is a tree that connects all the nodes without creating a cycle and has the minimum possible total edge, right? That's a plain, simple definition. You can read up on it if you want. But let's say you're given this, right? I'm going to show you how to create a minimum spanning tree using Kruskal's algorithm and then Prim's algorithm. So first you have Kruskal's algorithm. For this one, what you want to do is you want to take the smallest edge. So what the smallest is 1, 2, and then 2, 4, 4, 7, 7, 6, or 6, 7, 7. You take the smallest ones, but you only take it if you don't cause another cycle, right? And after that, you're going to find a way to connect all the nodes in the minimum possible way. That's the same thing Prims does. They're just two different algorithms to let you do that. Depending on the scenario, one might be better than the other one. Another thing you should know is that MSTs are not unique. Like you can have the same MST with the same minimum weight, but one of them will look slightly different than the other one. Let's do crystals first. So we want to find the smallest edge weight first, right? What's the smallest edge weight? Okay, it's 1. So this one's gonna stay. Next is 2. We can put this 2. There's another 2 here. We can put that one there. Next one is 3. Do we have a 3? We don't have a 3. Do we have a 4? We do have 4. Okay. There we go. There we go. Alright. Do we have a 5? We don't have a 5. Do we have a 6? Yeah, we have a 6. Let me connect those. Oh wait, that causes a cycle. Let's not do that then. 6 is no longer in our MST. 7. Is there a 7? Yeah, there's a 7. Oh, that's a cycle. Never mind. There we go. That's a 7. We're going to keep that. 8. Do we have an 8? Yeah, we have an 8. We have 2 8s. So this is what I mean by your MSTs are not unique. One of us is probably going to do this. The other one of us is probably going to do that, right? So you are going to get the same thing. You're connecting this 1 and 0 to your main MST. So you can choose either or. I'm going to choose this one. If I choose this one, I am no longer going to connect that one, because if I connect this one, that's going to be a cycle. Cool? Cool. All right, 8's done. Do we have a 9? Yeah, we have a 9. Do we have a 10? Yeah, we have a 10. But we don't even need to consider a 10 though, because we have all the nodes connected in an MST now. So all the other ones you can just erase. These are the paths that are redundant. This is all you need. And that's Kruskal's algorithm done. It puts an emphasis on the edges, right? And then you have Prims. Let's do Prims right now. This is the same one, so you can see how like they do basically the same thing. But it might not, if I choose a different node to like include in the MST might look different, but the minimum edge weights will probably be the same. This happens because like we have 2 8s, so one of us might choose a different one while the other person chooses a different one. But for Prims, you don't want to look at the edges, right? You want to look at the vertexes now. You want to look at the vertexes, and then you slowly want to grow from the vertexes. Your starting point of the vertex is your first point in MST. Then you slowly include other vertexes so that they're also now a part of your MST. But you always take the minimum edge if you have a possibility of choosing edges. You also don't take an edge that's going to cause a cycle, okay? All right. For convenience sake, I'm going to choose the 0 vertex to start off with, okay? All right. So 0. I have to choose between 4 and 8. I'm going to choose the minimum one. So I'm at 1 now. At 1, now I get to choose between 8, 8, and 11. Okay. So you see how I can choose this 8 or this 8? Just to show that you're going to get the same MST, I'm going to choose this 8. But you can obviously choose the other 8 if you want. All right. So our MST is slowly growing from the 0 vertex. Next up, I get to choose between 11, 8, 7, and 1. I'm going to choose 1 because that's the smallest one. There we go. All right. Next up, I get to choose between 11, 7, 2, 6. So I'm going to choose 2. That's the smallest one. All right. Next up, I get to choose between... I hope you know what I'm choosing between, right? I'm going to choose between 8, 11, 7, 6, 4, 14, 10. Obviously, the smaller one is 4, I mean. So I'm going to choose 4, right? Next, I'm choosing between 8, 2. I don't even have to do it. It's 2, right? So I'm going to choose 2. Now, I'm choosing between what and what. I cannot choose 6 because it's going to cause a cycle. I cannot choose 7. It's also going to cause a cycle. 11 will cause a cycle. 8 will cause a cycle. So let's not worry about that. But let's see. 6, no. 7, no. This 7, though. This 7 can work. All right. Let's see. I'm choosing... None of these work, so I don't have to look at that. I'm choosing 14, 9, and 10. 9 is obviously the smaller one, so I'm going to choose this one. All right, let me remove the redundant ones, the ones that are not part of our MST. Oh, actually, let me remove the 8 one. There we go. Look, you get the same thing. So Kruskals and Prims, they're basically algorithms that help you find the MST. Given a graph input, this is how you do both of the algorithms. Depending on which node you choose, when you have the same edge weight, you might get a different variation, but usually this is how you do it.